Hey everybody, this is Brandon from Sparksmith helping you see and be seen. Today I wanted to go over relays. If you're like me, you may find yourself laying awake in bed at night going, gee willikers, what is a relay and why do I need it? So a relay is essentially a device that uses a small current to control a large current. That's the short, simple, easy answer. The reality of it is a little more complex. But you've got two different types of relays. You've got your standard mechanical relay that you find in, all kinds of cars and trucks and whatever. You've also got something like what Diode has here, their solid state relay. And we'll get into the differences between these two and how they operate is a little bit different, but the end result is the same. You're using a little bit of current or a little bit of power to draw or to control a lot of power. One example of that, of course, is if you have, let's say, a light bar or something like that, and it's going to be something that draws a whole lot of power, and you want to use the tiny little switch to control it. Well, the little switch can only handle a couple of amps of current going through it, but the light bar is obviously going to draw more than that. So you use the switch to turn the relay on and off, and then the relay has a contact inside it that provides power directly from the battery to the light bar. And I cracked this one open earlier. I was going to show you what they look like inside. And usually you'll see these with either 4 or 5 pins on the bottom. The configuration is always the same. It's a kind of standard across the automotive world. You've got your power in from the battery, and then these two horizontal pins are the outputs, and the two on the sides are the control. So you put power and ground here, and you can see, so across this one, that goes to this coil of wire. And when you run current through this coil of wire, it turns it into a magnet. And that magnet will make this little arm move. If you can zoom in close enough, you can see like how this moves back and forth. And so that takes the power. So if you have battery power going here, it comes through this contact, through this arm, and then when this arm moves back and forth, it changes which one of these is getting power from this pin. And that motion is controlled by using a little bit of current to turn this set of windings into a magnet, and it makes this arm move back and forth. So that's kind of the basic gist of how a standard mechanical relay works. Is it's just a little arm moving inside, back and forth just a little bit, to use that small current to control a large current. I'm going to pull the whiteboard out and we'll go over a couple of details about how that actually works. Okay, so if we were going to draw this out as if it was on a diagram, typically what you would see is something like this, where you've got the cube and you've got your inputs and outputs. And so this part here represents this coil of wire. And then this represents, so this would be a standard 4-pin relay. On a 4-pin, I don't know if I have one. So if we were going to draw one of these out on a diagram, this is your standard 4-pin relay where these two sides go up to this same coil of wire that we talked about in the middle. That's represented by the part here. And then this arm is this little guy here, that part that moves. And then the two outputs on the 5-pin, or the single output on the 4-pin, is this right here. So you would have, typically what you'd have is this would go to the battery positive terminal. And then there's different ways you can control it. So the 3 lines here just means that's a ground. So that would go to any ground point or to the negative terminal of the battery. but the 3 bars indicate that it's going to ground. And then this wire here, so if you've got it connected and you run battery power to this pin here, is this one. And then you've got, let's say, your light bar or whatever thing that you've got to control on the other end is going to be connected to this pin that comes out here. And if you've got either one of these are not polarity sensitive, they don't care, you can connect either one of them to ground and then decide, you know, use a switch or something like that. So if you had a switch, just something that moves back and forth, could be a push button switch, could be a toggle switch, you know, whatever it is, that provides power. And when that circuit's closed, that gives battery power here, which turns this into a magnet, and it pulls this arm down and closes the circuit to provide battery power through the relay and out to the device. So the device is drawing power from the battery through the relay, and your switch is using a small amount of current to control the on-off of the circuit. Now this is kind of a generic diagram. There's a couple of different things you can do to create this switching function. We'll go over that next. Okay, so we were talking about different ways to apply power to the low current side of the relay. So obviously a toggle switch or something like that is one way to do it. Another way you could do it is, let's say you wanted this light to come on when something else happens. So if you had one that I've always kind of joked about, but I've never actually done it, is let's say you had your horn and you wanted your high beams to come on when you blow the horn. Well, the horn gets its power from, you know, we'll say that this switch is the horn button and it goes to ground. So when you press the horn button, you know, noise comes out. Well, if you tapped into whatever the positive wire for the horn is and tied that into that pin of the relay, this pin right here, then whenever you blow your horn, it's going to make that relay close and turn on whatever device. Same thing could be said for if you had, it doesn't have to be a horn, it could be whatever other thing. So if you've got another set of lights, like your parking lights or your, some kind of running light, or even if there was just ignition power, or even something like when you talk about doing fuse taps, that add a fuse kind of circuit where you come in and find a switched fuse circuit, and whenever the ignition comes on, you can put ignition power there, so whenever you turn the key on, or push the button or whatever you got, that would cause this relay to come on. So there's a bunch of different ways to use small amounts of current to control whatever big amount of current you got. So last thing I wanted to talk about on the relays was we looked at the mechanical relay and how it uses a small amount of current to generate a magnetic field and mechanically move an arm back and forth. Now, the other option that we talked about at the beginning was a solid state relay. That's a very different device because what it does is it uses electronics and smoke and magic to do basically the same thing, but in a non-mechanical, in a purely electronic way. So you got power and ground coming into it and power and ground going out. And then you'll have, like on these, for example, they actually have two input wires. So you can have two different things that will turn it on or off. And all these do is when they sense that 12 volts is there, so if you've got, your 12 volt source switched or whatever it is, when it feels that 12 volts, there's an IC circuit inside here that will allow the power to pass through. The biggest difference is that there's no current through here. So on this one, it's a very small amount of current, but by convention, I is current. You'll have like 0.01 amps, maybe. You know, it's a really tiny amount. But it takes some amount of current to generate that magnetic field. There are some vehicles out there, like some of the newer Fords and a lot of Mopar Chrysler products, that even a small amount of current like that can throw the system off. So they have to have something where your current is 0 amps. All it does is it senses that there's voltage there, and that changes the IC circuit behavior so that it allows the voltage to pass through. You can control higher currents typically with a mechanical relay. They're often rated for 30, 40 amps, whereas these, I believe, are rated for about 8 amps. So you're much more limited. But again, that's because of the IC circuit that's inside here and the microchip components that are controlling this current. So it's kind of the difference in how they work. Sometimes this is the right answer, having that solid state relay so it's not drawing any current whatsoever. And sometimes if you've got some big chunky stuff and you got a lot of power going on, you want something that's a little more heavy duty, like this guy. So there you have it, just a quick and dirty kind of lesson on what a relay is and when it's useful. Remember that it's a device that uses a small amount of current to control a large amount of current. Fairly simple devices. If you got any questions about how to wire them up, you can always hit us up, support@sparksmith.com. Thanks.